Hi students, okay, welcome to the class of vectors. Clear? So we already studied so many definitions in the vector chapter. We also studied some of the simple examples of the vector. So now we are going through some of a very important concept, that is components of vector. Clear? That means if you have one vector or if you know one vector, in that what are the components you must know. Clear? So for that reason, what I will do, I will represent in three-dimensional geometry. So I will represent a vector in three-dimensional geometry. So to represent a vector in three-dimensional geometry, what all components you are going to have, that is very important. Clear? So for that reason, first what I will do, I will take three-dimensional space. Okay, I will take some three-dimensional space. Origin, this is OX, this is OY, and this is OZ. So I have three axes. I have three axes here. Now what I will do, I will take 1, 0, 0 as one point. It is on x-axis. Simple concept, it is on x-axis. So I will mark this as A. Next I will go for 0, 1, 0. This is the point on y-axis. This is B. Okay. Now I will go for 0, 0, 1. This is on z-axis, that is C. Clear? So the length of OA, OB and OC, OA, OB and OC are unit values. That means 1 unit. Okay? Because it is on x-axis, it is on y-axis and it is on z-axis. So the length of these two things are 1 unit. So now magnitude of OA is equal to 1 unit, magnitude of OB is equal to 1 unit, magnitude of OC is equal to 1 unit. Are you clear? So now this is on x-axis, this is on y-axis and this is on z-axis. So if we want to represent a vector in three-dimensional space, these three things are very important, because this is called I cap, this is called J cap, and this is called K cap. Clear? So I cap, J cap, K cap are the three unit vectors in the direction of x-axis, y-axis and z-axis. Clear? So now if you want to write one vector, see this vector if I want to represent, that is a unit vector if I want to represent, I will represent it as with magnitude 1 unit, with magnitude 1 unit. Okay, so now please go through I cap, J cap and K cap, that is unit vectors in the direction of OX, OY and OZ. No problem. Suppose if you want to write any point, see this, if this is X, Y, Z point P. Now you want to write this point P in three-dimensional space. In three-dimensional space, then how you are going to represent this point P in three-dimensional space? First one, this is OP. OP vector has to be represented in three-dimensional space. So for that reason, what you have to do, see here, the magnitude on x-axis, on the same way the magnitude on z-axis, on the magnitude on y-axis you have to check. Clear? So for that reason what happens, this will be the magnitude of z-axis, this will be the magnitude of x-axis and this will be the magnitude of z-axis. So now this point is represented by vector OP equal to xi cap plus yj cap plus z k cap. So this will be the vector represented in three-dimensional space. Okay, where I cap, j cap, k cap are the unit vectors in the direction of x axis, y axis and z axis. Here x comma y comma z are scalar components. X comma y comma z are scalar components. Next, x I cap, y j cap, z k cap are vector components. Vector components. Okay, so these things are the basics that you must know in vector topic. Clear? So I cap, j cap, k cap are the unit vectors in the direction of x, y, z. Next, the length of I cap will be 1 unit, the length of j cap will be 1 unit, the length of k cap will be 1 unit in the direction of x, y and z. Another thing is, if you want to represent a point x comma y comma z in the space, then that point is represented by vector OP equal to xi cap plus yj cap plus zk cap, where xi cap is vector component, yj cap is vector component, zk cap is vector component. On the same way, x, y, z are the scalar components. Clear? This basics you must know. So after knowing this, let us go further how to add two vectors given, how to subtract two vectors given, and when two vectors are going to be equal. That things we shall study. Okay, students. So now what I will do, I will take two vectors, that is vector A is equal to, or I will take capital vector A is equal to A1 I cap plus A2 j cap plus A3 k cap. This is one vector, and the another vector is vector B equal to B1 I cap plus B2 j cap plus B3 k cap. Clear? So as you all know, A1 I cap is a vector component of vector A, B1 I cap is a vector component of vector B. Whenever you are adding two vectors, see this, if I want to add vector A plus vector B, if I want to add vector A plus vector B, what will happen to this? A1 plus B1 I cap. That means vector component of I cap and I cap has to be added. Next, vector component of j cap and j cap has to be added, and vector component of k cap and k cap has to be added, that is A3 plus B3 k cap. So this is how you are going to add vector A and vector B. Clear? Suppose if I want to subtract vector A minus vector B, what I will do? Same again, A1 minus B1 j cap, A2 minus B2 j cap, A3 minus B3 j cap. So this will be the subtraction or the difference of two vectors. This will be the sum of two vectors, that is vector A and vector B, and this will be the difference or the subtraction of two vectors, that is vector A and vector B. This has to be noted. Clear? Now if I want to say vector A is equal to vector B, if vector A is equal to vector B, then A1 must be equal to B1, A2 must be equal to B2, A3 must be equal to B3. That means the components that are scalar, that means scalar components of vector A and vector B has to be equal. Then only you can say that these two vectors are equal. Already we have written the definition of equal vectors, that is if if two vectors has to be equal, their magnitude and the direction has to be same. Clear? Then only we can say that they are the equal vectors. Clear? Magnitude in the direction of I cap, magnitude in the direction of j cap, magnitude in the direction of k cap. That is, scalar terms of I cap, j cap, k cap has to be equal. Then only we say that those two vectors are equal. This definition is also very, very important. Please remember this. Which that is, whenever two vectors are equal, their scalar components are always equal. That means corresponding scalar components are always equal. So in exam they can ask define equal vectors. So you can define equal vectors as two vectors or more vectors has to be said to be equal or has to be said to be equal if their direction and magnitude is equal. If their direction and magnitude is equal. Okay. So now please write that vector A is equal to vector B, then or if and only if A1 equal to B1, A2 equal to B2, A3 equal to B3. That means this components has to be equal for getting two vectors as equal vectors. Okay. By adding two vectors, you have to add I cap components, you have to add j cap components, you have to add k cap components. For the difference of two vectors, you have to subtract I cap component, you have to subtract j cap component, you have to subtract k cap component. Okay. So this is how you are going to add or subtract, and this is how you are going to understand two vectors are equal. Okay. Let us move for the next concepts. Okay students. So now let us move for the next some three important concepts, that is collinear of two vectors. Collinear of two vectors. Next, direction ratios of given vector, and direction cosines of given vector. Clear? Okay. So here first, collinear of two vectors. See, if you have one vector A, if you have one vector A with some 2 units, now what I will do, that 2 units vector I will multiply with another 2, that means lambda equal to 2. This is vector A. I will choose lambda value as 2. Now what I will do, I will multiply this lambda to vector A. I will multiply this lambda to vector A. Already vector A has 2 units. If I multiply this lambda 2 for vector A, now what it will happen? It will go for 4 units. That means lambda A will be 4 units, because already vector A has 2 units of magnitude. If I multiply with 2, now it will become 4 units vector. Clear? So for that reason what I will do, I will take this lambda A as vector B. Lambda A as vector B. Are you clear? So this is vector A. This is vector B. That vector B is nothing but what? Lambda times of vector A. What is lambda times of vector A? Lambda is multiplied to vector A. What is lambda? 2, scalar term. So that 2 is multiplied to vector A. Now it will double its length. Now it will double its length with 4 units, because 2 units of vector A. This is nothing but 2 units. I have taken some small example, 2 units of vector A. Now I will multiply it with 2. So it will get 4 units. It will increase its length. And this increased length of vector will become vector B. Are you clear? So now this is vector B. That is nothing but lambda times of vector A. Here one thing we have to observe, that both the vectors are in the same direction and they are parallel to the same vector. Both the vectors are in the same direction and they are parallel to the same vector. Are you clear? So therefore what we can say, vector B and vector A are collinear to each other. Vector A and vector B are collinear to each other. Are you clear? Because vector A and vector B lie on the same vector. See, vector B is lying on vector A because it increased its length from vector A. Okay, the continued part of vector A is nothing but B. So this kind of vectors are called collinear vectors. They are in the same direction and it is on the same vector. Okay, so now if you write B equal to lambda times of vector A, the condition for the collinearity is very important. The condition for collinearity is what? B equal to lambda times of vector A, then A and B are collinear vectors. If you write vector B as lambda times of vector A, then vector A and vector B are collinear. Therefore, see here what happens. If vector A equal to A1 I cap plus B1 j cap plus C1 k cap and vector B equal to B1 I cap B1 I cap, B2 j cap, B3 k cap. These are the two vectors, vector A and vector B. Now, these two vectors are collinear. That means, how you can write that? Vector A equal to lambda times of vector B. How you can write these two vectors? You can write it as vector A equal to lambda times of vector B. What it implies? See here. In the place of vector A, I will write the same vector A. What you are going to get? A1 I cap plus B1 j cap plus A1 I cap, A2 j cap, A3 k cap is equal to what? Lambda times of B1 I cap plus B2 j cap plus B3 k cap. I am using the condition of collinearity. That is vector A equal to lambda times of vector B. What is vector A? A1 I cap plus A2 j cap plus A3 k cap. Clear? So in the place of vector A, I have written vector A. In the place of vector B, I have written vector B. A1 I cap plus A2 j cap plus A3 k cap equal to lambda times of B1 I cap plus B2 j cap plus B3 k cap. Are you clear? So after writing these things, what happens? If you simplify that, A1 I cap must be equal to lambda times of B1 I cap, because if equal sign is present, it tells that these two vectors are equal. So if these two vectors are equal, what you are going to get? A1 I cap is equal to, or A1 is equal to lambda times of B1, A2 is equal to lambda times of B2, A3 is equal to lambda times of B3. These things you are going to write. Next, what happens? Lambda will be equal to A1 by B1, that is equal to A2 by B2, that is equal to A3 by B3. So this is nothing but equal to lambda. Clear? So if two vectors are collinear, then A1 by B1 must be equal to A2 by B2 must be equal to A3 by B3. If this direction ratios are equal, or the ratio of the direction ratios are equal, then we say these two vectors are collinear. Whenever we come across examples in the exercise, you will get more clarity. But first you must have an idea what is collinear vector. If A and B are the two collinear vectors, then vector A is equal to lambda times of vector B. This will be the definition. Vector A will be equal to the lambda times of vector B. Or one of the vector can be written as. So from this we have understood that if two vectors are collinear, one of the vector has to be written as scalar multiple of another vector. Clear? So that is, if vector A is written as lambda times of vector B, then vector A and vector B are called collinear vectors, and the ratio of their scalar terms has to be equal. Clear, students? Okay. Now let us move for the direction ratios. That is direction ratios. If you have a vector called as a1 I cap plus a2 j cap plus a3 k cap, let it be vector A. Here the direction ratios are a1, a2, a3. These scalar terms are called as the direction ratios. They are nothing but the scalar terms of a vector are called as direction ratios. Okay, very simple concept. If a vector is given, component of I cap, component of j cap and component of k cap are called the direction ratios. Simple. Previously we have studied as scalar components. That scalar components are nothing but the direction ratios. Okay, coming to direction cosines, very important. Direction cosines. First thing, direction cosines means the cos angle defined by x-axis with the vector given, and beta, angle beta defined by y-axis with the given vector, angle gamma defined by z-axis with given vector are called direction cosines. See here, if this is the three-dimensional space and I will take this is one of the vector alpha x-axis with vector A, beta with y, gamma that is with z. So alpha, beta, gamma are the three angles defined to the given vector with corresponding axis x, y and z. So now cos alpha is called cosine in the direction of x-axis, cos beta is called cosine in the direction of y-axis, cos gamma is called direction cosine in the direction of z-axis. Okay. Then how to find this cos alpha, cos beta and cos gamma? Very simple. See, here the vector is given as a1 I cap plus a2 j cap plus a3 k cap. This is vector A. This is a given vector A, that is a1 I cap plus a2 j cap plus a3 k cap. Now I want to solve cos alpha. Cos alpha is given by the formula a1 divided by root of a1 plus a2 plus a3. Clear? Cos beta is given by a2 divided by root of a1 plus a2 plus a3. This is also called as L. This is also called as M. Okay. And n is equal to a3 divided by root of a1 plus a2 plus a3. This is nothing but cos gamma. Clear? Cos alpha, cos beta, cos gamma. L, M and n. Now, if you are going to write the given vector with direction cosines, your vector A will be L I cap plus M j cap plus n k cap. Here, the same vector A is written in two forms. One with direction cosines, another with direction ratios. These two vectors are not different. Please remember, these two vectors are not different. Are you getting my point? So vector A is written with the direction ratios. The same vector A is written with the direction cosines. L I cap plus M j cap plus N k cap. I think you got clarity about direction cosines. Please remember this. Very, very important. Direction cosines means for a given vector A, it defines three angles with x-axis, y-axis and z-axis. Those three angles with cos theta is called as, or cos alpha, cos beta and cos gamma are called as direction cosines. How to define direction cosines using the direction ratios? These are the three formulas. Very, very important. You have to remember. Okay. Remark tells that L square plus M square plus N square is equal to 1. Please remember this remark. Let us solve it in offline classes, how L square plus M square plus N square is going to be 1. But for now, you have to remember these very, very important things. So please write a notes or write an assignment on the definition of collinear vector, definition of direction cosines, definition of direction ratios, formulas of direction cosines, and all those things has to be written in your assignment. Okay. So please make sure that these things are very, very simple. That means you have to practice. First thing, two vectors are collinear if and only if one of the vector is written as scalar multiple of another vector. Next, direction ratios, very simple. A1, A2, A3 are called direction ratios. Direction cosines, these three important formulas of cos alpha, cos beta and cos gamma. This has to be perfect. So from the next class, I start problems of your exercise 10.2. I will start solved examples and I will go through the exercise of 10.2. Okay.